Once again, good morning to everyone. Please take your seats. We are going to start the session. Again, you all are requested to please switch your mobile phone to silent mode. Please take your seats. Thank you.
ये रंजना मैम की यूके में रंजना मैम की जगह प्रेक्षा शाह बोल दीजिएगा। रंजना शिवराम की जगह पे प्रेक्षा शाह और ये इसकी जगह पे हाँ आप लीजिए प्रेक्षा शाह। सर ने चेंज नहीं करवाएगा? नहीं। ये मनीष सिन्हा की जगह पे नीरज वर्मा साहब आएंगे। श्री नीरज वर्मा
Member,
एडमिनिस्ट्रेटर एडमिनिस्ट्रेटर
distinguished guests, esteemed experts, visionary leaders, and delegates present here and joining online. It is with immense pleasure that I welcome you to the third meeting of Focus Group on Artificial Intelligence Native for Telecommunications Network FGAINN and Built-a-thon, Building POCs and Demos for AINN. This event is being organized by the Telecommunication Engineering Center, which is the standard setting organization for telecom and ICT technologies under the Department of Telecommunication. The Build-a-thon event is organized in association with Telecommunication, association with the Center of Development of Telematics, CDOT, which is Premier Research and Development Center under the Department of Telecommunication and Tejas Networks. And indigenous
Welcome
and
to
promising
the third
telecom
meeting
product
of
company of India, this event would provide a vital platform to connect, share insights, and discuss the current landscape and future of artificial intelligence in general and artificial intelligence native for telecommunication network in particular. Before we delve into today's agenda, allow me to briefly introduce what the Focus Group on AI Native for Telecommunication Network stands for. The International Telecommunication Union ITUT Focus Group on AI Native Network FGAI Native was established by ITUT Study Group 13 in July 2024 and was launched in WTSA 24. TEC from India has been pivotal in formation of the focus group and has been associated with the activities of group from start. Two meetings of this focus group have been held in November 24 and in April 25 respectively, wherein researchers, experts from all over the globe have collaborated and developed contributions aiming at exploring and defining the fundamental changes needed in network architecture to fully harness the potential of AI. The focus group meeting will be followed by the Build-a-thon event, that is, Building POCs and Demonstrations for AINN on 13th June 2025 to analyze FGAINN use cases, practical analysis of feasibility, and trade-offs by way of POCs for specific use cases and architecture concepts. This build-a-thon is especially a crowdsourced coding activity and will provide a hands-on experience in AI-driven network innovations. This event will serve as a platform for engaging researchers, industry professionals, and policymakers to drive innovation in AI-native networks. The Build-a-thon will have interactive sessions for in-person and remote participants, allowing for discussion, for presentations from experts and in the field of AINN. So now it is our utmost privilege to welcome all the distinguished dignitaries who have graced this event with their presence today. Your insights and contribution are what make this platform truly impactful. I warmly invite our esteemed dignitaries to kindly come forward and take their seats on the dais. For that, we extend our heartfelt welcome to Shri Sanjeev K. Bidwaiji, Member Technology DOT. Please come on the dais, sir. Shri Manish Sinha, Member Finance DOT. Oh, Mr. Neeraj Verma, Administrator DBN. I'm sorry. Mr. Sinha is not here. Dr. Atsuku Okuda from International Telecommunication Union ITU, Regional Director, Asia Pacific. Shri Rudra Narayan Pallai, Member Designate DOT. Shri Dev Kumar Chakrabarti, Member Designate DOT. Dr. Rajkumar Upadhyay, Chief Executive Officer C. Dot. And Srimati Tripti Saxena ji, Senior Deputy Director General and Head of Telecommunication Engineering Center. Please take the seats on dais. Thank you, everyone. To honor the presence of our esteemed dignitaries, we would now like to request officers from TEC to kindly come forward and present them with bouquet as a token of our respect and gratitude. For that, I now request Mr. Amit Kumar Srivastav ji, DDG Mobile Technologies, to kindly welcome Shri Sanjeev K. Bidwai ji, Member Technology. Mr. Amit Kumar Srivastav ji. And now I request Ms. Preksha Shah, Director, Satellite Monitoring Cell, to kindly welcome Shri Neeraj Verma, Administrator, DBN. Thank you. And now I request Ms. Jyoti Raut, Assistant Director General, TEC, to warmly welcome Dr. Atsuku Okuda, ITU Regional Director, Asia Pacific. Now I requested Ms. Namrata Singh, Director, TEC, to kindly welcome Shri Rudra Narayan Pallai, Member Designate, DOT. Now I request Ms. Khushbu Sharma, Director, TUC, to warmly welcome Shri Dev Kumar Chakrabarti, Member Designate, DOT. Ms. Khushbu Sharma, Director, TEC. I request Ms. Poonam Kumari, Assistant Divisional Engineer, Telecom, TEC, to warmly welcome Dr. Rajkumar Upadhyay, Chief Executive Officer, C. Dot. Further, I request Ms. Mudita Chandra, Assistant Director General, TEC, to warmly welcome Srimati Tripti Saxena ji, Senior Deputy Director General and Head, TEC. Thank you so much, everyone. Now, I would like to invite our respective dignitaries on the dais to kindly come forward and join us for the lamp lighting ceremony. As a sacred flame is lit today, let darkness and doubt fade away. With every spark, let wisdom rise and hope shine bright across the skies. This traditional ceremony reminds us that while we talk about the future, we stay rooted in the essence of unity and purpose. According to our rich tradition, no auspicious ceremony begins without lighting a lamp. This glowing flame represents enlightenment, positivity, and the beginning of a new journey. This will mark the official and auspicious beginning of today's program. A heartfelt thanks to our dignitaries for this auspicious beginning as the lamp's light continue to radiate throughout the day, that it reminds us for our collective commitment to knowledge, harmony, and progress. Thank you so much, everyone. Now, with great respect and warmth, I would like to invite Shri Shubhendu Tiwari ji, Advisor Technology, DOT, to kindly come forward and deliver the welcome address.
Respected Member Technology Shri Sanjeev Bidwai Sir, ITU Regional Director Ms. Atsuko Okuda, and distinguished dignitaries seated on the dais, esteemed delegates, speakers, international experts, FGAINN members, representatives from media, industry, academia, and young innovators present in this hall, besides those who have joined remotely, I, on behalf of Telecom Engineering Center, express my gratitude to all of you for accepting our invitation and joining this event today. I heartily welcome you all for this third meeting of the focus group on Artificial Intelligence Native for Telecommunication Network, FGAINN, and Build a Thon event. We are indeed proud to host this important focus group meeting, which is under ITT Study Group 13. The objective of this focus group are closely aligned with the research and development priorities of future technologies, not only for India, but also for the world. AI is transforming industries across the globe, and telecom is no exception. Telecom AI refers to those artificial intelligence technologies and solutions developed to support the evolving needs of communication service providers and other stakeholders in the telecommunication industry. In an AI native network architecture, a significant portion of network functions on both the control and user plane are powered by the AI. In fact, in AI native network, artificial intelligence is embedded in the core architecture, enabling unprecedented level of automation, optimization, and intelligence. While the full realization of an AI native network is envisioned for the 6G era, the foundation for this transformation will be laid in the coming years, paving the way for a future where AI is deeply embedded in every aspect of the communication network. In fact, ITU, in its vision document, has recognized artificial intelligence and communication as to be very important use case of IMT 2030, commonly known as 6G. AI native architecture will improve the telecom network by making it more intelligent, automated, and efficient. It will enable real-time traffic management, that is, prioritizing emergency calls during congestion, predictive maintenance, that is fixing a failing router before it causes outages, and energy savings, that is powering down unused resources at night. The focus group of AI native network will focus on several key objectives: researching AI integration in network architecture, identifying new use cases, addressing challenges and gaps, collaborating with other standard development organizations and industry groups to ensure a unified approach to AI networking. I would also like to mention that a Build-a-thon event has also been planned with the meetings of FGAINN, where many young minds will showcase their ideas in the domains of this focus group. It is an exciting complement to the standardization discussions and really completes the learning curve. The Build and Thon will showcase that the next generation of telecom engineers is not just participating in the future, they are building it. The focus group thus should use this platform to collaborate, communicate, and come up with new ideas in the field of artificial intelligence native for telecommunication network. Besides, lectures have also been planned on EINN from renowned experts along with this meeting. I again welcome everyone and wish this event a great success. And let us harness the power of AI networks to create a more connected, efficient, and innovative world. Thank you. Thank you.
Thank you so much, sir, for your kind words. Now, I would request Shri Avinash Agrawalji, Deputy Director General, International Relations, DOT, to share some important announcement to highlight India's strategic objectives within ITU.
Respected Member Technology, Administrator Digital Bharat Nidhi, Regional Director ITU, members designate DCC DOT, CEO CDOT, Senior DG and Head Telecom Engineering Center, esteemed delegates, distinguished guests, good morning. It is a great honor to welcome you to the third meeting of the ITUT Focus Group on AI Native for Telecommunication Networks. On behalf of the Government of India, I extend our sincere thanks to the ITU for its leadership in global digital cooperation. India's journey with the ITU began in 1869. Our partnership has always been guided by the values of inclusivity, innovation, and sustainability. Today, India is making rapid strides in technology like 5G, AI, and quantum communications. We are also looking ahead to shape the future with 6G. For us, technology is a tool to bridge the digital divide, create opportunities for everyone, and build an inclusive digital economy. Our commitment extends to the heart of the ITU's work, standardization. We believe that good standards build trust in technology. To this end, our national body, the Telecommunication Engineering Center, is actively contributing to the ITU for developing global standards. It is also developing national standards to ensure new technologies serve humanity equitably. I am happy to share that TEC has developed one of the world's first standards for assessing fairness in artificial intelligence. Our commitment is also reflected in our people. Indian experts contribute actively across the ITU's work. We are proud that they hold leadership positions in all three ITU sectors on the Council and within the APT, including its preparatory groups for WTSA, WTDC, and WRC. We believe in partnership through action. Our collaboration with the ITU is stronger than ever. In the recent past, India has proudly hosted several key events. These include the opening of the ITU Area Office and Innovation Center in New Delhi, the ITUT Study Group 9 meeting in Bangalore, ITUT SG3 Regional Group Asia Oceania meeting in New Delhi, a lot of other meetings of the area office, and most significantly, the World Telecommunication Standardization Assembly WTSA 2024, along with its lots of side events, including Kaleidoscope, AI for Good, Network of Women, and others. The experience of hosting WTSA has given us great confidence. Building on this momentum, India wishes to host the ITU Plenipotentiary Conference in 2030. We humbly seek the support of all member states for this endeavor. It would be an excellent opportunity to showcase our commitment to a digital future and share India's rich cultural heritage. As we say in India, Atithi Deva Bhava, the guest is equivalent to God. Our engagement with the ITU is a long-term commitment. As a member of the ITU Council, India has always worked in the interest of all members in our region. We hope to continue this important service. Therefore, India will be seeking its re-election to the ITU Council in 2026. To further strengthen our contribution, we are proud to nominate an exceptional candidate for the 2026 elections. We have put forward the name of Ms. Revati, she is present here, a current and respected member of the Radio Regulation Board, for the post of Director of the Radio Communication Bureau. Ms. Revati would be the first woman from the Asia Pacific region nominated for this vital role. We seek your invaluable support for our continued service on the Council and for Ms. Revati's candidature. In closing, I thank our partner countries. Your support enables us to achieve great things together. We are guided by the principle of Vasudhaiva Kutumbakam, the world is one family. Let us work as one family to build a connected, prosperous, and shared global future. Thank you. We have a very brief video, if it could be played.
What began with a single telegraph line has today sparked a revolution. From accessibility to affordability, from scale to global leadership, India's telecom journey is one of bold transformation, shaping a billion futures with the promise to support and connect the global community. For over 150 years, India has been a trusted partner at the International Telecommunication Union as a voice of innovation and inclusivity. Since 1952, we have served as a member of the ITU Council, contributing to global telecom policy with purpose and progress. From championing fair access to empowering developing nations, India stands for a connected and inclusive world. As we seek continued support for our position as a member in the next ITU Council, we reaffirm our resolve to leave no one behind in the digital revolution. A distinguished technocrat with 29 plus years of expertise, Ms. M. Revati is a global voice in spectrum management, satellite coordination, and regulatory diplomacy. Currently serving on the ITU Radio Regulations Board, she has helped nations reclaim satellite rights, building digital equity across continents. With this legacy of global cooperation and telecom governance, we proudly present the candidature of Ms. M. Revati for Director, Radio Communication Bureau, ITU, 2027 to 30. If elected, she will be the first woman ever and the first from Region E to lead the Radio Communication Bureau. Let us support this historic and inclusive candidature for a more balanced and representative future. Seeing the world as one family with one future, India has been a proud host from G20 to most recently WTSA 2024, welcoming over 3,700 delegates from 194 countries. These global gatherings have showcased India's international connectivity, state-of-the-art infrastructure, and capacity to deliver tech-driven, high-impact events. Building on this legacy, India proposes to host the ITU Plenipotentiary Conference 2030 with the world's largest connected youth, a thriving tech ecosystem, and deep experience in global digital cooperation. India is not just ready to host the future, India is ready to lead it. Let us support India's position for ITU Council Member 2027-30, Ms. M. Revthi for Director BR ITU, and India as the host of ITU Plenipotentiary Conference 2030. Together, let's shape the next chapter of global telecom. Together, let's connect the world.
Thank you very much.
Thank you so much, sir. Now, we have a short video message from Mr. Cizo Onoy, Director Telecommunication Standardization Bureau, ITU, welcoming all the participants of ITUT FGAINN. Please show the video.
Welcome to the third meeting of ITUT Focus Group on Artificial Intelligence Native for Telecommunication Networks, FGAINN. May I thank Dr. Neeraj Mittal, Secretary of the Department of Telecommunications, Government of India, and his team at the department for graciously hosting the meeting, which will serve as a platform for engaging researchers, industry professionals, and policymakers to drive innovation in AI-native networks, as well as driving the pre-standards activities in ITUT. This focus group aims to uncover the requirements, challenges, and opportunities that AI-native networks will unleash on the global communication stage. These cutting-edge networks promise revolutionary automation, intelligent optimization, and self-management, powering the next generation of applications with unmatched agility, precision, and lightning-fast performance. The group continues to progress various deliverables that will shape the future ITUT standards in terms of AI integration in networks. We will work on a gap analysis, craft a clear shared vocabulary, develop an AI-native architecture framework, and create proof of concept. Excitingly, here a crowdsourced coding event will bring together brilliant minds through interactive sessions in person for library discussions and expert presentations, driving innovation in AI-native networks like never before. Thank you in advance for your participation, and I wish you every success in this meeting and the road ahead.
Thank you, sir, for your thoughtful words and virtual presence. Thank you. Now, I would request Ms. Atsuko Okuda, ITU Regional Director, Asia Pacific, to come and address the participants.
Esteemed dignitaries, distinguished colleagues, good morning. It is my honor to join TSP Director, Mr. Seizo Onoe, in welcoming you all to the third meeting of the ITUT Focus Group on Artificial Intelligence Native for Telecommunication Networks, hosted here in New Delhi by the Government of India's Department of Telecommunications. I extend my deepest gratitude to Dr. Neeraj Mittal, Secretary of DOT, and his dedicated team for their outstanding effort in organizing this important event and for their unwavering commitment to fostering innovation and collaboration in the digital sphere. As we convene today, we are reminded of the unique position that Asia and the Pacific occupies in the global telecommunications landscape. Our region is not only the fastest growing digital economy, but also a vibrant hub for research, development, and policy innovation. The rapid adoption of new technologies, coupled with a dynamic ecosystem of startups enterprises, and research institutions places us at the cutting edge of the digital revolution. This meeting, therefore, represents a unique opportunity to shape the future direction of AI native networks, a future in which intelligent, self-managing systems will drive extraordinary levels of efficiency, security, and service quality. The importance of AI native networks cannot be overstated. These networks promise to revolutionize the way we connect, communicate, and collaborate. By embedding artificial intelligence directly into the fabric of network infrastructure, we unlock the potential for real-time automation, predictive analytics, and adaptive optimization. This will not only enhance the performance and reliability of our networks, but also lay the foundation for new applications and services that can address pressing societal challenges, from bridging the digital divide to supporting smart cities, healthcare, and education. In this context, the work of FGAINN is both timely and essential. The group's focus on gap analysis, shared vocabulary, architectural frameworks, and proof of concepts will provide the building blocks for robust, interoperable, and secure AI native networks. The crowdsourced coding event and interactive sessions planned for this meeting are a testament to the collaborative and inclusive approach that defines our community. By bringing together researchers, industry professionals, and policymakers, we foster an environment of open dialogue, knowledge sharing, and co-creation. As ITU Regional Director for Asia and the Pacific, I'm particularly proud to see the diversity of expertise and perspectives present here today. Your contributions will be critical in ensuring that the standards and frameworks we develop are not only technology sound, but also equitable, inclusive, and aligned with the needs of our region's diverse populations. And on that note, I am very happy to share with you that with the generous support of the Government of India, ITU opened the Area Office and Innovation Center in March 2023 and have been supporting to connect the Indian innovations to the rest of Asia and the Pacific, such as the Pacific countries as well as Southeast Asia. Let's use this opportunity to strengthen partnerships, share best practices, and inspire actionable outcomes that will accelerate digital transformation and sustainable development. Thank you once again for your commitment and participation. I wish you a productive and engaging meeting. Thank you.
Thank you so much, ma'am. We truly appreciate your presence and message today. Thank you. Now, with great honor, I would like to invite Shri Sanjeev K. Bidwaiji, Member Technology, to kindly come forward for the keynote and inaugural address.
Good morning, everybody. Madam Atsuko Okuda, ITU Regional Director, Asia Pacific, my dear colleagues, Neeraj Verma sir, Administrator DBN, Rajkumar Upadhyay ji, CEO CDOT, my colleagues, member designate Shri R.N. Palai ji, Dev Chakravarti ji, my dear colleagues Shubhendu Tiwari ji, Advisor Technology, Senior DDG TC Tripti Saxena, BSNL Directors, CMD, TCL, other senior officers of DOT available over here, my dear friends, esteemed delegates, technologists, industry representatives, and ladies and gentlemen. It is my honor and privilege to address this distinguished gathering at the third meeting of Focus Group of Artificial Intelligence for Native Networks and the Build a Thon event. I warmly welcome all esteemed delegates, technologists, policy leaders, industry representatives, and most importantly, our young innovators. As we already know, focus groups are special entities under the ITU framework created to rapidly develop standards in emerging and strategic areas while operating with a high degree of independence. Although linked to a parent study group 13 of ITU-T, these focus groups enjoy flexibility in working methods, participation, financing, and outputs. Their deliverables, such as technical reports or specifications, can either remain standalone or be proposed for elevation to ITU-T recommendations through the study group's formal processes. The ITU-T FGAINN was established, as we already know, in July 24 by Study Group 13 and officially launched after WTSA 24. Its objective is to explore and define the architectural and functional transformation necessary to realize AI native networks and to address the emerging requirements, opportunities, and challenges that such networks will bring to the global telecom ecosystem. AINN signify a fundamental shift in the design of telecommunication systems, where artificial intelligence is not merely an add-on but embedded into very fabric of network architecture and core functions. Unlike conventional networks that integrate AI on top of legacy systems, AI native networks are born intelligent, designed to autonomously adopt, optimize, and respond in real time to changing network conditions and user needs. They represent an evaluation from autonomous networks of 5G, which focused on self-configuration and automation using externally attached AI modules. In contrast, AI native networks integrate AI capabilities natively, allowing real-time data-driven decision-making, adaptive service delivery, and dynamic use cases discovery. This intelligence-driven design supports multi-domain coordination and continuous learning, which are essential for the demands of 6G and beyond. The 3GPP has been integrating AI across multiple domains of mobile networks through functions like network data analytic functions and management data analytics functions. 3GPP is making strides in embedding AI for intelligent orchestration, automation, and service optimization, key ingredients for AI native designs in 6G. According to ITU Arts Vision Document M.2160, AI will be a key enabler for future networks, from intelligent radio interface management to cross-domain orchestration and personalized service delivery. In fact, ITU in its vision document has recognized artificial intelligence and communication as to be a very important use case of IMT 2030. AI native networks will not only manage complexity, but will unlock new service frontiers, immersive digital experiences, autonomous systems, integrated sensing, and on-demand slicing for verticals. This evolution is not just technological, it is strategic. AI native design allows us for adaptive security, resilience, and energy efficiency, all of which are crucial in today's interconnected world. India is well prepared to lead and contribute meaningfully to this transformation. Our nation is home to one of the world's largest and most dynamic telecom markets, offering a rich and diverse testing ground for AI native solutions. Government of India's initiatives such as Digital India, BharatNet, establishment of 5G use case labs are laying the groundwork for advanced digital infrastructure. Institutions like CDOT, IITs and other leading R&D centers are working on indigenous AI-powered telecom technologies, actively contributing to international standards through platforms like ITU-T, ITU-R and 3GPP. Moreover, India's expanding AI startup ecosystem, backed by supportive policy framework in AI, data governance and digital public infrastructure, makes us not only ready but also global through leader in shaping the future of AI native networks. Recently, India has launched Bharat Jan, India's first indigenously developed government funded AI based multimodal large language model LLM for Indian languages. Bharat Jan aims to revolutionize AI development across India's linguistic and cultural spectrum. Bharat Jan integrates text, speech, and image modalities, offering seamless AI solutions in 22 languages. Aligning with Prime Minister Shri Narendra Modi's vision of India TechAd, Bharat Jan is seen as a national mission to create AI that is ethical, inclusive, multilingual, and deeply rooted in Indian values and ethos. The initiative also supports the National Education Policy 2020 by promoting interdisciplinary learning, enabling students to combine technical and humanities discipline. IIT Jodhpur, in partnership with Center for Development of Telematics CDOT, DOT is developing AI frameworks for automated network management, fault detection, and diagnostics. This includes establishing a real-time 5G and beyond testbed compliant with ORAN standards. Further, DOT has signed a letter of intent with ITU to explore AI-driven digital twin technologies for infrastructure planning. This collaboration also supports PhD research in telecom technologies, reinforcing India's commitment to global telecom research and standards. Through these initiatives, DOT is positioning India at the forefront of AI native networking, fostering innovation and contributing to the evaluation of intelligent, autonomous telecommunication networks. India is regarded as the skills capital in technology and artificial intelligence. The most reliable ranking in AI is placing India among the top countries with AI skills, AI capabilities, and policies to use AI. Stanford University has ranked India among the top 4 countries, along with US, China, and UK, in the global and national AI vibrancy ranking based on 42 indicators. Government of India is committed to harnessing the power of artificial intelligence for the good of our people in various sectors. At the same time, government is cognizant of the risk posed by AI and the need to create guardrails to ensure that AI is safe and trusted. While AI and AI native networks hold transformative potential, we must proceed with awareness and responsibility. Key challenges include ensuring the explainability and transparency of AI-driven decisions, especially in time-sensitive and mission-critical scenarios. Data privacy, security, and sovereignty are paramount, particularly as AI models rely on large and varied data sets. There is also a need to address bias, fairness, and ensure that regulatory and interoperability frameworks evolve alongside technological advancements. Responsible AI implementation with robust safeguards and human oversight is essential to maintain public trust and network reliability. I am especially excited and happy about the Build-a-thon segment of this event, a unique platform where bright minds will not only present bold ideas but also prototype them, collaborate on real-world problems, and generate solutions that are both innovative and impactful. To all developers, students, mentors, and engineers, this is your moment. Use it to question assumptions, explore new frontiers, and contribute to technologies that can redefine the future of communications. The Department of Telecommunication remains firmly committed to fostering innovation, enabling global and domestic collaboration, and supporting the development of next generation technologies like AI/NN to build a secure, inclusive, future ready digital ecosystem for India and the world. I wish you all 3 days of inspiring discussions, path breaking ideas, and boundary pushing creativity. Thank you very much. Jai Hind.
Thank you so much, sir, for your insightful words. Now, I would request Srimati Tripti Saxena ji, Senior Deputy Director General and Head TEC DOT, to offer vote of thanks to the dignitaries.
Good morning, ITUT Regional Director Asia Pacific, Madam Atsuko Okuda, members of Digital Communication Commission, Administrator Digital Bharat Nidhi, CEO CDOT, and esteemed members of audience. This is indeed a privilege for us to host this third ITU2 focus group on artificial intelligence native for telecommunication network meeting and Build-a-thon. I would like to convey my gratitude to the members of Digital Communication Commission, Administrator DBN, CEO CDOT, for gracing this inaugural session of this event with their august presence and guidance. I owe special thanks to Madam Atsuko Okuda for being here and highlighting the importance of this endeavor in the field of AI native in telecommunication network. Also, I would like to convey my deep sense of obligation for the members of the focus group who will be sharing their learnings and insights in this forum so that the group can work towards achieving the objective of this group. Lastly, many thanks to the members of the audience whose presence always inspires the incumbents to put in their best efforts. Thank you. Thank you all.
Thank you, ma'am. We would again like to extend our heartfelt gratitude to all the respected dignitaries and visionary leaders for taking time out of your busy schedule to join us today. Your presence and contribution have truly added great value to this occasion. We would also like to thank all the participants who are present here or have joined remotely. Your continued support, efforts, and contributions have played a key role in shaping today's event. Thank you so much. Also, I would like to mention that participants may visit Ericsson's stall, which is just outside Hall 5, where they are demonstrating important concepts and ideas about artificial intelligence native for telecommunications network. With this, we have come to end of the inaugural session of this event. We have arranged high tea for the participant in Atrium Hall. We will begin the session at 11 sharp. We kindly request everyone to be seated on time to ensure a smooth and timely start of the session. Thank you. Welcome back, everyone. Welcome back to the third meeting of Focus Group on Artificial Intelligence Native for Telecommunications Network, FGAINN, and Build-a-thon building POCs and demos for AINN. To open our first session, we would like to invite Professor Brajesh Lal from IITD, who will enlighten us today on imagining telecom through the lens of AINN. But before we start the session, let me share a brief introduction about him. Professor Brajesh Lal at the Department of Electrical Engineering and Head of Bharati School of Telecommunication Technology Management at IIT Delhi holds a PhD in Digital Signal Processing from IIT Delhi 1999. With over 25 years of experience, he has served as a professor since 2018, following roles as associate and assistant professor at IIT Delhi and as a member of the DSP group at Hughes Software Systems. His expertise spans AI, ML, computer vision, 5G and beyond, and signal processing. He has supervised over 40 PhD students and led projects worth over rupees 100 crores, including 5G test beds and AI-driven initiatives. With over 300 publications and 10 patents, he is a leading figure in telecommunication and AI innovation. Over to you, sir.
Morning, everyone, and hello to everybody else, depending on where they are in the world. Thank you very much for having me over, and thank you for allowing me to speak before Professor Ganti. Otherwise, there'd be little left to say. But you'll have to wait a little while longer to hear Professor Ganti tell us a few interesting things as well. So, can we have the slides up, please? Or how does it work? Yeah. Oh, yeah, fine. Now we see them. Great. So let's move to the first slide. And what is it that we're trying to do? So why are we talking about reimagining telecom in the AI neural network lens? The reason for trying to do that is that most other sectors have taken to AINN, realized its worth and value, and made it part of their ecosystem like it is the go-to tool, and there is a reason for that. It has really proved its worth in a number of applications. In today's presentation, what I'll try and do is talk about a few things. First, we'll try and understand why are we talking at all about AI/ML in the space of telecom. Then we'll try to understand the perspective of AI/ML and the opportunity that this brings for India. And finally, I'll talk about a few research opportunities that exist, which are quite important from India's point of view. By no means is that list comprehensive. The list, even for India, is much longer, and for the globe, it is way, way longer. I think the time has come for us to accept that AINN is here to stay, and the sooner we embrace it, the better it will be for us. Can we move to the next slide, please? All right, so we begin with trying to understand what is it that we're talking about when we say an AI native network. So there will be three kinds of networks that I sort of allude to during this presentation. So, well, not three types of networks, three types of settings. One is where you'll use or leverage AI for networks. In the others, you'll leverage networks for AI. And then finally, there's something called AI native. All have their place, But eventually, when the dust settles, we're hoping that it would be AI native, which will incorporate both those aspects. Formally, networks designed from ground up with AI as a core component is what you would term as AI native networks. Now, AI, for those of you who've worked in the area of telecom would know that we as a community took a long time to accept AI as a possible tool. We had been using it in different forms, business intelligence, data science. At the core, it had been used for a very, very long time. But closer to the cell phone, the physical layer folks took some time in accepting this. But now, those are days of the past, and we really are looking at AI very, very keenly. So in today's talk, we'll try and understand why it should be native and how it can be made native. And if that does happen, what does it mean for India? So before that, let us understand how typically AI works and how is it different from automation. When you talk of automation, you still allow the machine to do something on its own, but it is primarily rule based. You already define the things that you want it to do. So there is no learning, so to say, involved. It is not improving based on the feedback or based on the data. All that it does is repeatedly, correctly, precisely every time what the rules tell it to do. So automation is a good thing, no doubt, because it brings accuracy, precision, repeatability, and a lot of other benefits, eventually leading to efficiency and cost advantages. But then that is just one way of using the machines. A much better way of using the machines is to make them learn, churn a lot of data. So that is how AI is the next step in automation. So automation allowed you to give a lot of control to machines, but only for defined tasks, and these tasks were rule based. There was no learning involved. The machine would do nothing different the next day, irrespective of what happened around it. It had a set of rules and it continued to follow them. And that is something that will change. Now, this has both advantages and disadvantages. We worry about the ills. We worry about the fact that, we might lose control, which is also true. But if we do a very conscious and limited and controlled deployment of AI, there is more advantage to be had than worrying about the ills that it might bring to the ecosystem. The other thing that very briefly I talk about is when we talk of AI, that at a very high level, three ways of learning. One is what is known as supervised learning. The other is what is known as unsupervised learning, and the third is reinforcement learning. The reason I bring this up is that you will realize that we need to use all three in telecom. Why do we need supervised? Supervised learning is when the machine learns from the data and the data has both input and the target output. So it's supervised. You already know what answers to expect for a particular question or input, if you prefer. In unsupervised, you still have data, but only input data. There is no target, so to speak. So you can still perform tasks such as clustering. You can put a lot of data together based on similarity of its features or characteristics, and then you can take the next step. So that's where unsupervised learning plays a role. And then finally, there's reinforcement learning, which is the most important thing that we will have to sort of take care of. You hear about agentic AI. Agentic AI is essentially implemented using reinforcement learning. In reinforcement learning, what happens is you learn from the environment. You still have input data. When you input the data to the system, it will produce some outputs. Those outputs will then interact with the ecosystem, resulting in certain changes. Those changes are then interpreted as reward or penalty and fed back into the ecosystem to improve your method. So reinforcement learning is something that we will need to use a lot of as we give more and more control to the machines. You will have to move away from giving it lots and lots of data. You will have to allow it to sense its environment. And that's where it gets even more frightening, because you are now allowing it to choose and pick the data that it reads, interprets, and makes sense of. But, again, reinforcement learning can also be deployed in a controlled manner. So these are the three kinds of, at a very high level, AI techniques that exist, and we need all three of them. We have, to an extent, been using supervised learning for a long time now in data centers, for example, and in the core, you have already been data mining. Data mining, data science, business intelligence are terms that we've been hearing for about 15 years now, if not longer. And they are essentially an area of machine learning. How are they different from the AI that we're talking of today, the neural network based AI? The difference is that until this point in time, we were creating features out of the raw data. You collected data from the environment and you weren't able to use it ab initio. You understood the physics of the phenomenon and tried to create features which were apt for the task at hand. So what happened was that a lot of effort went into this feature engineering, and it sort of slowed us down. The second problem was that our understanding of the physics of the phenomenon was incomplete. And worse, the maths that we used had its own limitations. So you had two constraints, and therefore the feature engineering that you ended up with was suboptimal. However, when you allow AI access to raw data, you allow it to do the feature engineering, followed by the inferencing tasks that you wish it to do, recommendations, classifications, or regression, or whatever else your requirement is. So that is how AI today is different from the relatively traditional ML that has been around for some time already. So that we must understand. So the AI that we talk of today is a different breed, and therefore we could, in a manner of speaking, say that now we are moving into increased use of AI in telecom networks. Can we move to the next slide, please? Now, this is what I alluded to very briefly early in my presentation. I talked about AI in networking. Clearly, there is a role to play there. You set a network up, and using that network, you want to perform certain tasks. AI can help you understand your network, it can help you understand your consumer, and therefore you can provide better services. On the other hand, AI today is not standalone. It is implemented in a federated, distributed, in a manner which moves away from a single central deployment of the algorithm. Therefore, underlying network which is robust and reliable is an imperative. Unless you have that, the AI will not serve the purpose that you intended to. However, this is not where we wish to stop. As telecom engineers, we want to move to what we now call AI native networking, which includes both. So not only will the network somehow be optimized so that AI can run on it well, you will have the capability to optimize the network based on the AI tools that you have built in. So if I read out, you will be able to self-configure, self-heal, something that you hear a lot of. Downtimes are a big problem. Recovery from a disaster is something that we worry about. Ultra low latency and high bandwidth. When you give control and processing to the machines, you end up reducing the latency. And better processing leads to higher bandwidth, because while we don't have time for it here, but humans consume information very differently from machines. So when we are humans, we are quite interested not just in the content, but also in the manner that it is displayed. The visualization of the content sometimes becomes important for us. However, machines are only interested in the information, which leads to higher compression, more reliable inferencing, and as a result, increased bandwidth utilization. Of course, the improvements that you make to the network also lead to higher bandwidth, but bandwidth utilization is also more optimized. Intent-driven automation across the full life cycle. Intent is another word that you'll hear a lot of in times to come. We are no longer interested in telling the machine specific tasks. We want to move to a state where it understands the intent. It's like a board meeting where the CTO has to understand what technologies he has to deploy so that the goals of the company are met. What is the intent of that particular meeting? You don't have to translate into tasks or assignments and then give to the machine. So intent understanding right from the very beginning is something that will become very, very commonplace. And that will ease our life even further. We are expecting the machines to understand us, not just what we are saying, but what we are trying to say, our intent. And you see a lot of that happening already in the chat GPT. I think some or most of you have used chat GPT at some point in time. And you might have realized that it understands you way better than Google search did. This is at the lowest level, understanding your intent. So what will now happen is that the intent is what the network will understand because it's AI native, and it will respond accordingly. Now that's a huge plus because you no longer have to make micro corrections. You only have to make macro corrections. You know, we want to be profitable this quarter, or we want volumes this quarter. No, that's much easier to specify than convert it into a set of deployments, a set of customer campaigns and the others. So it becomes quite complicated. So the same intent will now become part of networks. So the network manager or orchestrator will give to the AI in the ecosystem its intent. How does it want the network orchestrated? And the rest of it would all be imagined and implemented by the machine itself. Clearly scalable AI. It's much easier to scale machines. It is way more difficult to scale trained manpower. That is a struggle that we continue to have in India. We might be a large population. We might have a large number of engineers. But when we look for trained manpower, almost always we fall short of the requirement. And that is a vicious circle, because if you don't have trained manpower, then you produce less and your requirement goes down. And it keeps on feeding into itself, and instead of increased jobs, it leads to loss of jobs. However, if you make your networks AI native, you build scalability into it, because machines are easily replicated and easily scaled. There's much more flexibility when you're working with machines. Seamless edge to cloud AI deployment. What shape will edge take? It will become a reality because it does not make sense to have all levels of intelligence at all layers of the network. So here what is going to happen is that you will have split control even. Compute, of course, is being split, and communication related tasks have already been split across network elements. But what you will see is control being split across all of these. So what essentially will happen is that you will have seamless edge to cloud deployment. Edge meaning a user equipment at one end, followed by possibly a near or far edge and the core, and then possibly the internet and the other end could be in another network, for example. Finally, amongst other things, you'll also end up with reliable and deterministic network performance, because that is what machines are good at. They will do exactly what you tell them to, as long as the inputs are within the constraints of what you taught it to do. So when we worry about AI, we don't worry about a situation that we've already trained it for. We are worried about it encountering situations that we did not train it for. How will it respond to situations that we did not have data to train it for? However, we have to deploy it in the field, and however unlikely it might encounter that. So that is where there's an issue. But if you do a controlled deployment, it is absolutely repeatable. So you know exactly what it is going to do. When you send a mechanic out to fix, there is some degree of subjectivity in how he'll handle the problem, how he will try to fix it. But no such subjectivity if it is done by a machine, because it will do a set of steps. It will either work or it won't, and you know exactly what it is going to do. Next slide, please. Now, here's a pictorial depiction of what I've been trying to tell you. State is where your network is right now, meaning during operation, it is in a state of being. Learning history is because it wasn't brought up right now. It has been up for a period of time, and during that time, it has had the rewards and penalties that I talked about in reinforcement learning. It has also had supervised and unsupervised learning instances and offline training where weights are regularly updated. So there's a learning history that it already has in the ecosystem. You also have what is known as context, and this context is quite important, because what happens is, in a country as diverse as India, the context is very, very varied. As you move from one place to another, the expectations and desires of people change, and therefore the context changes. So, you might have areas where people want more data versus areas where people want to talk more. So context, learning history, and finally the state that the network is in currently, all of this together constitutes what we now wish to call as the knowledge or the intelligence plane. We don't know what name it will take, but you'll certainly have to add a plane to what already exists. The data plane, the control plane, and the management plane already exist in telecom network. But you'll have to look for a fourth plane in one form or the other. You probably call it knowledge, or you call it intelligence. But there will be a plane that will sort of seep into the ecosystem, and soon we'll all need to talk about it. And then you have this AI engine, which takes all of this in and optimizes, predicts. Classification is one of the tasks that it might perform. Can we move to the next slide, please? We need to move a little quicker. Let's move to the India context. We'll skip a few slides. They will be available to you too. Please move to the next slide. Okay, AI enabled, AI native, I already explained, and this pictorially represents what I've already been saying. You move away from training individual components, giving it then rule-based capability. Well, not necessarily rule-based, learning-based, but at least the learning was much more controlled as opposed to AI native, where there's more control that the machine has over how it responds to the ecosystem. Next slide, please. This is, again, I hope this is visible. So here what we are saying is, let's look at this very, very quickly. You have data that is generated, you observe that data, you perform analytics on it, which is used for guiding. Now this is something that has already been done in telecom. But however, the insights that you draw can then be used by a human campaign manager to probably stop churn, or you could put it back to a machine and it performs cognitive tasks. Based on those cognitive tasks, you'll have decisions. And those decisions will lead to actions or orchestration in our case. And that orchestration will lead to a new set of data points because there'll be an action. That action will result in a changed network setting, which will then result in changed data, and the cycle repeats. So this is what is happening, and in the middle, you have what is known as knowledge evolution and inferencing. So the system continues to learn from what good or bad happened based on the decisions that it made using this loop that we see here. Next slide, please. All right, now this is something that I'll spend a little time on. Why should we worry or at least see this as an opportunity? India has 1.2 billion plus mobile subscribers. Now the thing is that a rural digital gap continues to persist. The other thing is that AI networks, this is a new paradigm which is beyond automation. Now there are a couple of things to understand here. In telecom at least, a lot of automation that you are implementing works on COTS. Some places you need to optimize the hardware, But India is some distance away from having its own high quality hardware. However, there is enough that can be done on software, and therefore the AI networks, which are a new paradigm, and they represent um, uh, um, um, an improvement beyond automation, is something that India can look at because of the relatively larger component of software in it. And finally, based on these two, what we're trying to say is that the vision, the technology should be for inclusion and not just innovation. We're not saying innovation is bad, but inclusion is what is important. A biggest example of this, and this is not India specific, 5G was announced, standardized, deployed with so much fanfare. There was huge innovation that people talked about. However, at least in India and a lot of other markets, all that 5G means to you is higher bandwidth. The key technological innovations that it was supposed to bring, they're really hard to be found on ground. Because tech wasn't inclusive, so to speak. You did not hear your customer. You did not know what your customer wanted. You tried to push something down the throat because you thought it was exciting. You thought it was something that the people needed. So inclusion is extremely, extremely important. So when you talk of an India-specific AI enablement or an AI story, inclusion means understanding the entire population, not the few of us who live in large cities, who might be excited about innovations of a different kind. We need innovations which make it easier for our larger population to improve their lives. It makes it easier for them to continue to reside where they do at a higher level of living standards. So it has to be inclusive. So when we target this AI in making it native in telecom, we should make sure that the rural and in India, fortunately or unfortunately, remote also means rural. World over, remote can sometimes mean areas where very few people stay or go to. But in India, mostly all places are populated. And when you say remote, you're probably talking rural. Next slide, please. All right. So, what can the rural imperative do for us? So what are the challenges? Limited bandwidth, high latency, poor QoS for critical services, inconsistent network reliability. And why are these things happening? Because those markets do not appear to be as profitable as the other markets. And why does that happen? Because the standard was, or the deployments were designed based on urban markets. So the revenue model, brilliant for urban, is quite poor for rural. They did not include the needs of the people in remote rural areas while they were designing the technologies, and hence they will not get revenue from there. It's not as if those people are not spending, but they are spending on things that matter. How did FMCG respond to a reduced demand some months ago? By making smaller packets. It responded. But here what we do is we sit here, try to understand what we need, and then based on that make a technology and say, wow, what a wonderful technology, it works for us. Why are they not benefiting? Why are the service providers not willing to go to those remote rural areas and deploy? Why are they not able to make money when the technology is so brilliant? Because it is not inclusive. So this is the opportunity that we have. We could pick rural up, and this clearly is not the only thing that we can do. The second thing is we do have test beds. So since we have test beds, IITs, DOT, CDAC, CDOT, Tejas, TCS to mention a few, let's leverage those, build a lot more software and algorithmic solutions on top of them, become a strong contributor to the 6G ecosystem, and finally, exportable AI native frameworks for the global south. get like-minded nations together, provide facilities to them, possibly get them on board for certain issues. But in the end, what we want is to do these three things. Look at the rural and make it part of our technology strategy. Leverage the test beds because we are primarily looking at software and algorithms. And finally, service similar markets and find like-minded partners and make our impact much, much larger. I'll stop at this, run out of time, but I'm happy to take questions. Yeah, please. Networking of AI. Yes, so that is networking for AI, correct. So we needed both. So if you saw, there was an arrow that was going from AI for networks, networks for AI, and both of them fed into the AI native. Mm-hmm. Mm-hmm.
We have already very good standards in IT,
Mm-hmm.
and so many. So whether we are using those standards or not, I think at least India will start.
That is very, very correct. See, just because we are moving towards intent does not mean that we can do away with standards. All the research that is going into quality of experience, standardization related to AI, or any standardization for that matter, if anything, the standardization has to be made stronger. So you bring out a very, very valid point, because I said AI is good only if the deployment is controlled. And without standardization, that will be hard to achieve. Yeah, thank you for that point question.
Different countries are using different standards.
And
For developing nation like India and all, if we should, I think, take initiative in that.
We should take initiative because it matters more to us than it does to them, and therefore we can and we should participate. Thank you. Thank you. Interesting comment. Yeah, please.
Yeah, so you spoke about understanding the intent. Now, understanding the intent can lead to different interpretations, and that can be really challenging. So, how do you plan? Do you have any thoughts on that?
Okay, so understanding the intent is not something that happens day one. Understanding the intent is something that improves over time. So what happens here is when you move from giving defined tasks to allowing the machine to understand your intent, you take baby steps towards understanding intent. Those of you who used Google 20 years ago would remember that how poor the search results were. Those of you who used it 2 years ago will recall, before ChatGPT became popular, how much better they had become. And then they became worse because there were a few sponsored in the beginning, and then you got the real material, but that's a different matter. So what happened is it took 20 years for that to evolve, and we let it evolve because it wasn't hurting anybody. So when I say intent, I don't mean that they'll start with intent. What I mean is they'll graduate to intent, and that could take 20 years, 10 years, 15 years. The level of intent will move from low level intent to higher level. Rule based is essentially the lowest level intent fed to the machine. And when I say intent, I mean moving to a place where the highest level intent can be fed to the machine directly. It won't happen overnight.
I would still say that you still would require a lot of safeguards in terms of defining the intent, because it can still
so now that is a very, very good philosophical point as well. See, the problem is our understanding of the world, the way we look at the world, is based on how would a human react. Okay, now human reacts in multiple ways because of our conditioning. We are afraid to tell lies because it has implications. We are afraid to steal because it has implications. We are afraid to do wrong things because it has implications. Some of us cheat because that gives them easy money, right? So, but because we know how humans behave, so we've learned how to deal with it. So there's this justice system which works in a way that it does. The problem with machines is that there is nothing that worries them. So you cannot chain a machine based on the consequences, because all the consequences that it knows are the consequences that it's been exposed to. There is no need for self-preservation. So the way they look at intent is very different from the way we look at intent, and therefore, to answer your question, their intent has to be monitored and monitored differently. But human intent is also monitored. You just don't hire somebody and ask him to do anything that he wants. He has to give a weekly report. There's a monthly report going up. So there's a hierarchy already. So intents are already being monitored. But because that mechanism is so well in place that we don't realize it's happening. With machines, because their intent has to be managed differently, we will have to do exactly what you say.
Actually, on earlier occasions, the technology, whenever a new technology used to come, and it used to be absorbed very fast. Possibly there was a inner demand and there was a serious requirement to the people, to the government. But nowadays, I think there is a race of innovation and the new technologies. And by the time the newer technologies are coming, we are almost into the domain of marketing. We are marketing technologies to be adopted by the industry, with academia, by the people. I mean, is it a good trend to happen?
Absolutely not. This again is because of the human need to survive. The greed of the business houses is driven from the need to survive. This is a primal instinct, cannot go away. The fact that we are living things, we are genes which survived, is because our forefathers had the survival instinct. So this is not something we can wish away. But as government, because we have government representatives here, we have standardization representatives here, it is our duty to make sure that regulations and policies inhibit incessant, very fast, unplanned growth in technology. You can have sandboxes, do what you wish, but before it is let out, you have to take a very, very considered decision. You cannot let people's fears or greed drive the technology deployments. And to answer your questions, another question, the thing is that technology is changing very quickly. These are incremental changes. AI has been around for 75 years now, but it caught on now because the hardware was only available now. Same thing happens with the tech that we made in 5G. We don't need all of it. And some of these things might become very, very popular 6 or 8 years hence. So that's the other aspect. But as far as your question is concerned, you're very right. The governments and standardization bodies have a very, very important role to play. Thank you.
Thank you so much, sir, for making the session truly insightful and informative. Thank you. And now I would like to invite Professor Radha Krishna Ganti from IITM. Professor R.K. Ganti is in the Department of Electrical Engineering at IIT Madras. He holds BTech and MTech degrees from IIT Madras and a Master's in Applied Mathematics and PhD in EE from the University of Notre Dame. His research focuses on digital communication, convex optimization, and cellular systems. He has received many prestigious awards. He contributed to 5G base station development and is currently working on 6G test beds. Today, he will be sharing his insights on AI/ML for next generation wireless networks. Over to you, sir.
Good morning, everyone. First, I'd like to thank the organizers for having me here. It's a pleasure to meet all of you. So today, Professor Brijesh has set the stage, has nicely explained the high-level things of what AML has to be, at least in the context of wireless networks and cellular networks. I'm going to build upon that. You're going to see a little bit of overlap between what we are trying to say, but we'll start from there. Next slide, please. I hope you recognize who this gentleman is. It's Shannon. Okay, so we are all in this room because of this particular gentleman, what he has done in the 40s. Okay, He has given us the single most, at least from a communication perspective, the single most greatest formula that engineers and scientists have been chasing for the last 50 years to reach that. That is he set the goal, and all of us have been trying to reach there, okay? So because of this, AML in communication is a little bit different from AML in networking and other fields. I'll just take a couple of slides to explain what is the difference, okay? So in communication theory, digital communications or wireless communication, the fundamental limits are known. So if you look at a cellular system, if you say that I'm a transmitter and a receiver, I can tell you what is the maximum amount of data rate that is possible. I can exactly tell you what is the latency that is possible. I can also tell you how that can be achieved, okay? And this is being achieved. If you take 4G, for example, 4G or 5G, at least theoretically, they're all optimal in terms of performance. That is the way the communication, the whole area of communication has evolved in a very, very different way compared to either networking or in other general scientific fields. So in communications, and wireless communication, what happened is that, first of all, we knew the limit. They said that, okay, for this particular channel, this is the best possible thing. Then people started trying to achieve the best. Okay, so we did coding theory, we did modulation, we did OFDM, MIMO, so on and so forth to reach this. Okay, so it's a very hard thing for AML now. We are already at close to what is the best possible thing. Now the question is, what can AML do more to this? Okay, so if the capacity of a channel is 50 bits, 5 bits per second per hertz, and you are at 4.9 bits per second per hertz, you put AML on that. What is it going to give you? Okay, so that's the question I'll try to answer today. Okay, so whereas in networking, if you take networking evolved in a very different manner. The theoretical fundamentals of networking couldn't answer a lot more. I mean, see, the networking became so complex so fast that we don't know the limits of networking. Okay, so if you look at computer science and networking, algorithms evolve. Algorithm works. If it's good, we accept it, but we still don't know it's the best. That's not the way in communication works. Okay, so this is a very, very fundamental difference. Okay? So the question, but while I'm saying this, so it's very, very hard to ignore AML anymore. I mean, I have resisted AML for about last 5 years, and then it turns out AML is pervasive everywhere. I mean, you can't write a paper now without AML. Okay, that's the way it is. And everyone is talking, there's something to it. Okay, it's just not, we cannot neglect it anymore. Okay, so what is it that AML can provide wireless communication? Next slide, please. So this is the formula, okay? So with this formula, we can explain 2G, 3G, 4G, 5G, and I don't know what is going to be in 6G. So it says the capacity, okay, I'm just going to explain this in words. The capacity of a wireless channel is N times W times log 1 plus signal to interference noise ratio, okay? N stands for, I mean, if you generalize it a bit, N stands for the number of antennas. W stands for the bandwidth. S stands for the signal power, I stands for the interference, okay? So up to now, if you take from 2G, 3G, 4G, 5G, one of the things that we have been doing is increasing W. 1 megahertz, 2 megahertz, 10 megahertz. In 5G, it's 100 megahertz, and in 6G, hopefully it will be 400 megahertz or something, okay? That is how we are reaching capacity. N, the number of antennas have been scaling up from 4G to 5G. We know how to do it exactly. Okay, we have mastered that. There have been like 100,000, I mean, tens of thousands of PhD theses on it. We exactly know what to do. Yes, S is the signal power. How do you get better signal power? People are blasting off too much power from the base stations, or you reduce your cell size. That's how you get signal power. Interference, how do you manage interference? There are lots of ways of managing. I mean, that's how you do cell planning. You do interference management, okay? So we have been playing with all the variables. Effectively, I don't think any more variables are left to extract juice out of this equation. I think we have played everything, okay? In 6G, people are talking of making N crazily to 200 antennas, W to be 500 megahertz, so on and so forth, okay? So, but where does AML fit into this picture? Okay, so if you look at it closely, most of the times the optimizations are individual. So you generally optimize antennas. You generally optimize the bandwidth, or you generally optimize the interference or the signal power independently. But if you look at from a whole system perspective, up to now, I don't think any system, including 4G or 5G, looks at the joint optimization. There's a reason for that. The reason for that, it's too damn complicated. Okay, there is no simple way of doing a complete system level optimization. Okay, we are fundamentally limited by our ability to understand the math of it. So this is where AML may play a role. That's one big place where AML might play a role. Again, I'm saying might. I'm going to give you some examples. Okay, so so we are very. That's why I put an approximation there. We are very close to that. So where exactly is this, is AML going to close the gap, or is AML is going to do something more, is what we have to understand. Next slide, please. Okay. Saying that, I mean, so I'm going to disagree with Professor Brijesh on this. Communication guys have been using machine learning in some form or the other from some time. Okay, I mean, while I agree with his point that it's a rule-based mechanism, whereas AML is more intelligence-based mechanism, I think drawing that line is a little bit different. So recently, a couple of days, I was listening to a talk by Professor Chandramurthy from ISC. He was very adamant that he says that the proportional phase scheduler used in cellular communication is the precursor to reinforcement learning. I agree to it. Okay, we have been using AML from some form or the other. Okay, let me tell you this thing. Let me give you a brief idea of that. Shannon, we talk about message detection. Shannon's theory talks about message detection. Okay, that's exactly equal to classification and machine learning, high dimensional classification and machine learning. Network scheduling. So every network, you take 4G or 5G, you schedule the users. You say which users have to talk when, which users have to be in QoS requirements. This is equivalent to reinforcement learning or maximizing reward for using agents. Okay. So if you look at a little bit more fundamental, like channel estimation feedback. So essentially, we are estimating channel based on the channel feedback from the users. We adapt our network. That's what is happening in 4G and 5G. This is exactly equal to unsupervised learning. Okay? So there are similarities. So because there are similarities, maybe machine learning can fit in very well. That's what we have to take it for. It's not like we're already doing it. Why should we do this? The thing is, already we are doing this. So this has given us this kind of performance. Can we build upon that to make our life either easy or increase our performance? That's what we have to understand. Next slide, please. Okay. So these are the reasons why I would at least consider AML. So if you look at Shannon's formula was derived based on some assumptions of the channel. Okay, it's called additive white Gaussian noise channel, those of you who have looked at this. So the way theory developed in communication, we have a channel model. We have a specific channel model. And from that channel model, we derive a theory, we derive algorithms and try to implement it. But in reality, what happens is your reality is never equivalent to that model. It's finally a model. Okay, so model comes from a lot of assumptions, a lot of, you do some experiments and come up with a model. So where we are finding advantage of AML in communication is, a lot of times the channel model is not correct. If the channel model is correct, we are doing optimal. But the question is, channel model itself is not correct. Okay, because so for example, we assume models given by 3GPP, okay, in terms of fading and in terms of other things. But they are models, they are not correct. Okay, so this is where data-driven approaches make a lot more sense. So the gap that is coming is because our modeling is not exact, and it will never be exact. We should never even try to be exact. Okay. The other thing, this is a point I was alluding earlier. So we do block by block optimization. We say that I'm optimizing RAN network, I'm optimizing, someone else is optimizing core network, someone else is optimizing application level. We never optimize the end-to-end systems. Okay? It's complicated. We know that if you optimize this, we're going to get a lot more gain, but it's too difficult. And this is where, again, AML can play a role. Okay, so it can look at the whole system as a whole and then try to do an optimization. Okay? And one more thing that's happening right now is incredible power in hardware. I mean, now I think most of the SoCs have NPUs and GPUs integrated in this. It will be a shame that we do not use it. So I think given that this hardware explosion is anyway happening, it's actually a time to use AML or machine learning kind of an architecture to improve your system as a whole. Next slide, please. Okay. So what are the challenges in AML? Okay. So essentially, I'm talking with the hat of an telecom engineer. So one thing, as Professor Brijesh pointed out, is data. Who has the data? So essentially, all of you know that any AML algorithm requires training, and training happens on data. So where do you get this data from? If you look at it right now, only the people who have this data are the network operators and bigger companies, maybe because they have deployment. So this is a question that as government agencies and regulators, you have to answer. So we are making standards based on AML. We are saying that I am going to utilize this AML model in this so on and so forth. But so how can a small incumbent come into this market and build products without having access to the data? Okay, so this is a big problem. Data sets is a very, very, very big problem. And the second thing, this is again, I think this is going to become a problem in the next decade. No one wants to learn communication anymore. No student wants to learn communications. Okay, I'm pretty sure this is the same thing in other fields also. Since I teach communication TSP courses, I'm telling you this. No one wants to learn communication. No one wants to understand cellular. Everyone wants to do only AML. Okay, so these days the way we handle that is we put AML in front of every course. That's the easiest way to attract students. But this is something that is, so we are forgetting our core domain. Okay, so we have built all this expertise over the last 60 years, last 70 years. And now we are suddenly saying that, okay, you have the data and there's some magic that happens because of the data and it will solve your problem. That's not at all correct. Not at all correct. I mean, expertise in domain knowledge is still very, very significant, and this is something I don't know how to solve this problem. You should have domain knowledge and then apply AML on that. Otherwise, you cannot make sense out of AML at all. Okay? And the third thing is, how do you build AML networks? Okay, how do you build AML hardware? How do you build AML networks in a cost-effective manner? Okay, so we are talking about training, network training, NVIDIA GPU. I know how, I assume all of you know the cost of a single NVIDIA GPU, $34,000. Okay, I mean, so for a single GPU card. I mean, so how do you enable a more cost-effective, essentially to do inclusive kind of deployments? How do you do this? I mean, this is something that we have to think about from the scratch, from the beginning. How do you build an AI-enabled network? It's not like you just put things together and it becomes an AML network. That's not an optimal way of things. Okay, and the whole life cycle of AML is something that we have to start understanding and getting together for. Okay, I had to go a little bit fast. Next slide, please. Okay, so I'm just going to go through this. So people are talking about native AI networks. Okay, again, this whole workshop is about native AI, but I have a different view of native AI. I don't think, I mean, see, at this point, there are research results which say that two AI agents can communicate with each other over wireless channels. There are results. I'm not denying that. Okay, but they are too far from practicality. They're very, very too far from practicality. Okay, so the way AI is going native, so AI is going to get into our networks is it's not going to rip off your existing systems. I'm not going to replace my base station with an AI-enabled, with a pure AI base station anytime soon. Okay, the reason is AI is unexplainable at this point. AI is a black box. Okay, so even with the current system, if something is wrong, the whole set of people in the companies do a blame game, saying that, oh, my core network is correct, your RAN is wrong, RAN guy will tell L2, L3 is wrong, so on and so forth. In an AI kind of a system, it's almost impossible. If it works fabulously, it works perfectly. But if it doesn't work, you really don't know why it doesn't work. Okay? So this explainability of AI is something very, very critical before we deploy this as a pure AI agents in a commercial kind of a networks. Okay? So what I believe is that AI is going to coexist with the existing system for the next generation of networks. It's not going to rip and replace it. It's going to coexist, and aid the existing network. So for example, if you have a receiver, I'm not going to replace the conventional receiver with an AI receiver. It's going to sit there. Both of them are going to talk to each other like friends and learn from each other. And hopefully over another decade, things are going to move across. Okay, so this is a whole life cycle management of AI. I'm going to go a little bit fast. Next slide, please. I have another 5 more minutes. Okay, so this is a dream. AI at every layer. Part of this is going to happen. There's going to be AI at MAC layer, scheduling. There's going to be AI at physical layer. But as I was telling you before, at least I'm talking to a lot of engineers from Ericsson's, Nokia's, and other companies also. No one is at this point confident to do a pure AI-based system. AI, both of them are coexisting, and that will certainly improve the performance. Next slide, please. Okay. Again, this is the same thing. We want AI everywhere. The question is, how do you do this? Next slide, please. Okay. So I'm just going to spend a minute on this. Brijesh has talked about this. One is AI for network, another is network for AI. So AI for network is what a lot of engineers like me are interested in it. How can I use AI to improve my 5G systems or 6G systems or networking systems? Okay. So in a cellular system, both mobile and cell phone has to participate. Okay. So now there's a big problem happening in 3GPP. Should only cell phones participate in this AML, or should network only participate, or both of them should talk to each other, and how do they talk to each other? Okay, this is where standardization is coming into picture. Okay, so for example, like you get a phone from Samsung, how can it interoperate with an Ericsson base station when there are AI agents in both these things? Okay, so how do you define these interfaces? This is where ITU and 3GPP is going to play a very, very big role, and this is what is happening precisely in 3GPP right now. Next slide, please. Okay. So as of now, there are specific problems that people are trying to address in this AI for network. Okay, so for example, how do you do channel feedback? How do you do localization? How do you do receiver enhancements? Okay, so what way does native AI fit in picture? So for example, a simple example would be, so every base station has something called digital pre-distortion. Okay, so essentially your amplifiers are all non-linear and you try to linearize their amplifier using conventional algorithms. Okay, this is very, very important for power efficiency of the base station. So for example, people want to use AI to solve this particular problem in a more efficient way, which is fantastic. And this is where AI should be used, and they are trying to use this. So this is again, I assume that this is native AI. So as I said, again, how do you do end-to-end design instead of a block-by-block design? And the other thing that if AI has to come into networks is how do you debug AI? Yeah, this is one thing that people are not looking at, and this is something that people should also emphasize. Okay, I'm just throwing problems. I don't know the solutions to most of this. Next slide, please. And network for AI is, already AI is being used on 5G networks and 4G networks. So what is the new thing that you require? So now what might happen is these models may coexist, may be partly in the network and partly in the mobile phones. So how do they talk with each other? How do you make this more efficient of sharing models across base stations and networks? Okay. How do you do federated learning? How do you do learning across multiple UAs? So this is where network for AI comes into picture, and again, very exciting area of work. And this is ITU is also looking very, very deeply in network for AI and trying to come up with frameworks and standards for this. Next slide, please. Just can you please go ahead a couple of slides? Yeah, next slide, please. This one, please. Okay, I'm just summarizing what I told. What I say, conventional is the current systems and AML is this. Conventional systems are more algorithmic in nature and as rule-based in nature. AML systems are data-driven in nature. And conventional systems are specific to specific models. That's what I was telling. So we have a specific model, and from there you derive an algorithm. AML things are a little bit more model agnostic. Hopefully AML gives you better or similar performance. The conventional thing, the biggest strong point of conventional systems is it's explainable and debuggable, whereas AML systems are almost a black box as of now. From a hardware perspective, if you take the conventional as a baseline, AI systems require more hardware. Okay, hardware intensive, it requires NPUs, GPUs, and so on and so forth. Convention, so again, here is one thing that standards should actually, this is a point of discussion that 3GPP and ITU should make. What are meant by AML standards? Okay, so AML conventional system, if someone has a standard, anyone can implement it. It does not matter. I mean, you just give them a standard document, they can sit down and implement it. It's difficult, but people can implement it. But that is not the case with AML. Only people who have data can implement it. So how do you bridge this divide? This is something that we have to look at. I'll say these systems are going to coexist and not replace each other. Okay. Saying this, we'll go to the last slide. We have been doing a lot of work. I mean, I have been doing some work on AML. I'll show you a positive result on AML. Just go to the last slide, please. Almost the last slide. Please go back. Go. Next slide. Next slide. Next slide. Yeah. Okay, just be here. So I'm going to show you an example where AML plays a role. So this is called a, don't worry about the jargon, I'll explain you. It's called a physical air control channel. Okay, so when you switch on your phone, the first thing that the cell phone does is it tries to latch onto the network. When it tries to latch onto the network, it sends some control information. So this information goes on a channel called PUSCH channel, physical uplink control channel. It's a very, very simple channel. It wants to communicate only 3 or 4 bits of information. So what it does is, it sends a specific waveform. For bit 1, it sends one waveform. Bit 2, it sends a different waveform. 3 and 4, it sends a waveform. Conventionally, what do? You receive this waveform and figure out which waveform it is. If it's 1, you say 1 bit was sent, 2 second waveform, so on and so forth. This is a very, very perfect example of what AML does with classification. Okay, so now currently our 5G test bed and all the base stations implement this PUSCH format 0. It's called format 0 receiver. Without this, your cell phones don't work. Okay, just go next slide. Next slide, please. Yeah, next slide. Yeah. So this is a conventional let's not worry about what it is. This is how the conventional workflow is. So it gets the data, it does a DFT, it does correlation with the waveform and tries to find which waveform was transferred. It's a very complicated, it's a complicated setup, but nevertheless it works almost very well. Next slide, please. Next slide. Okay. So what we said was, so we already have the conventional system. So what happens, how do we replace this conventional system with a neural network? Okay, neural network classifiers are the most primitive AML models. Okay, I mean, this is the one which everything started with. So when there's ReLU, I mean, so many networks on this. So we picked out one nice network and we want to utilize this. Okay, next slide, please. Okay. So, okay, training. So how did we train with this? We trained it 2 ways. The first method, we generated artificial data using MATLAB. Okay, MATLAB is a software where you can write your code and generate this artificial data. Okay, so we generated the data and trained the network based on that. And what happened was so we trained that and it worked perfectly well. I mean, so the training was synthetic data, and then we tried to use the network again on the synthetic data. It worked perfectly well. But the moment then what we did was, anyway, we had at IIT Madras, we had the 5G test bed. So we actually captured what is the receive signal from the test bed and applied to the network. It failed miserably. Okay, it did not perform at all. I mean, it was very, very bad. That's when we realized that training this, so the data that is required to train this kind of network is very, very critical. Okay, I mean, otherwise your model size just blows up. And if you want the generalization, your model just becomes so big that it cannot be implemented in a reasonable thing. Next slide, please. Then what we did was, we trained it with we captured the data in a painstaking manner from the test bed and augmented that training data with the MATLAB data. And then it started performing extremely well. Okay. So if you look at this, let's not go into the details. What it says is accuracy versus signal to noise ratio. Okay. So the bottom blue curve, if you can see the bottom blue curve, is the conventional system. Okay, by the way, conventional system is also optimal. Technically, you cannot beat it. It's known to be optimal. It's an ML, maximum likelihood receiver on the other side. Okay, and that is the red curve is the neural network thing. Okay, so you're seeing that for a given SNR, the performance of a neural network is slightly better than maybe 3%, 4% better than what happens, what is there in the conventional system. Okay, the reason that we were able to find out was because we made some assumptions in the conventional system, this gain is happening. But you see that the gain is not so significant. like 3%, 4% gains, okay? And this is what you're going to see in typical communication systems with AML enabled. You're not going to see 40% gains, 50% gains. That is not going to happen. Okay, you're going to see 5% gains, 6%. So now this question you have to ask is the cost worth it? Okay, this is something that we have to make a decision. So I'm going to stop here. Next slide, I'm just going to conclude. Next slide, please. Yeah. So AML for wireless is here to stay. There are two reasons. One, because everyone is talking about it, and now all the engineers are getting trained in AML. So they are going to be the next ones who are going to implement it. So it is going to become part of wireless. Okay, so there's no denying it. Domain knowledge should not be underestimated. Okay, and we have to figure out a mechanism of training the younger generation on this whole domain knowledge. It should not be lost. Okay, so the question and the next thing is, how do we generate data sets? Here is where test beds are going to play a very, very critical role. If we want our startups to work on AML, they require data, and the only way we can give is through test beds on real life deployment. We have to figure out a way, okay? And we have to look at the fundamental underpinnings of AML to do explainability, to make it more robust. We have to understand how to debug, but at least for the next few years, both of them are going to coexist. And hopefully think this will make our life better. Thank you. I can take a question. Sure. I can take a few questions if you have, please.
Sir, I have a question.
Yeah, please.
So, I'm Avijan Bhattacharya from TCS. Being from communication background, I do share many of the views that you have expressed, and also while I take interviews for my company, I also kind of force people to go back to signal processing rather than saying ML. So I have three questions. Number one, that stems from what Professor Lal actually said. When we talk about bridging the digital divide, given the trend of Moore's law, how it is saturating and how the cost is increasing, will AI native network help us in bridging the digital divide in terms of cost of the service that we are going to have in future? That is number one. Number two, I appreciate what you have said, because I spent first 10 years of my career doing all this channel equalization for a company in UK, and also turbo decoder and all. We have done all classification algorithms, log likelihood ratio, everything we have done. And now we talk about clustering and all in the context of AI/ML. When I first encountered with AI, a network model, it kind of reminded me of this Fourier transform, fast Fourier transform and all these things. Given that, today all computer science is contributing to AI/ML. Do we also think that the signal processing engineers have a much larger role in terms of making AI explainable and understanding which signal processing block in a layer is actually misbehaving when you are talking about debugging? And my third question is, for Shannons, the first thing that we understand about information is that the sink does not know about what is going to come. That is where your information is maximized. In the paradigm of semantic communication, what we see is that it is triggered that the sink is actually going to generate the information from very minimal hint from the source. So is it going to disrupt the entire concept of information theory and all? Yeah. These are three questions. Thank you, sir.
I'll start with your second question. So, okay, so I'm an electrical engineer, so I always have a conflict with the computer science people. So computer science people design algorithms and then leave the analysis to electrical engineers. Okay, that's what generally happens. So most of the theoretical developments are actually being done by electrical and signal processing people. So there are lots of signal processing people who are now working on AML, trying to explain, getting to the fundamental limits. There's no denying it. See, essentially, this is all convex optimization. These are our bread and butter tools. So I don't think there's a dearth of people now working on, signal processing guys working on this. Talking about the second question about semantic communication, this is a very interesting field. So for Shannon, bits don't mean anything, they're bits. 0 is a 0, 1 is a 1, it doesn't mean anything. Whether you send a long text or a small SMS, it does not matter to him. So now through semantic communication, people are trying to say that meaning means each message has a meaning, and the meaning is what is important and not the message itself. Okay, so this is a very, very paradigm shift from the way Shannon started his whole information theory. I don't know where it's going to where it's going to go. I mean, I don't think Shannon's theory is going to be junked or anything. I mean, I think the same set of people are working on semantic communications also. Hopefully, because of the semantic communication, we'll have more compression, and that will help us improve the performance. On the first part, the digital divide part, the cost, that is something we have to be very, very conscious now. How do you do training and how do you do training, GPU's cost, all this. I mean, that's what exactly I'm trying. We have to get back to the drawing board and figure out how do you build AI networks. It's not like you buy servers from somewhere, just put it there, connect everything, and it's just going to become a magic network. I don't think that's going to be cost effective at all. We have to think about where AML is required, how do you do it properly. Some engineering has to be done. Thank you.
Sir, this side.
So please.
So this AI actually depends upon the data and good quality of data and good number of volumes of data. So actually in the whole telecom network, if you see, if we deploy AI in all the subsystems in a controlled manner, then system may work in a better way. But if system fails, then what? This is a big challenge.
Yeah.
And as you pointed out, sir, startups are looking for the data sets. So we can give a stale data of 1 year or 2 years older data to do experiments. But again, data privacy comes in picture. So this is a real challenge that we have to address together.
Yeah, this is absolutely. The first point you raised is if AML models don't work, then we don't know why they don't work. It may be because of training issue, it may be because it has never seen that data. So many issues are there, we don't know. Okay, so that is why I'm saying that at least until we answer this question, both of them have to coexist, and we have to learn that thing. Second thing, from coming to a data perspective, there are two parts of a network. One is the RAN network, another is the core network. Okay. So generally, you only have data about the core network. Even DOT or anyone's, I mean, the final call traces is what you'll have. Okay, so that maybe you can anonymize and provide it to companies under NDA or some kind of. You have to figure that modality of how to do this anonymization and other things. Okay, at least maybe multiple points of the core network. RAN is a much more complicated piece because how do you even store data in a RAN? Who has access to that? These are things that I think we should sit down and address this. I think TEC and DOT have to spend some time if really we want our AI companies to succeed. Okay, so other thing is test beds. So from our perspective, so we generated. So we are going to put out all the data sets that we generate from test beds out in the open. But saying that they're also limited. So it's all a test bed, like 3-4 base stations that we are generating data. But what you require may be larger data sets. This is a problem that we have to figure out. I mean, that's what is going to make or break our AML dreams.
Thank you.
Thank you.
Yeah, one small. Basically, you've given certain items where this AI in native network or telecom network is possible, like in CSI estimation or some other aspects. Yes, Professor Lal actually threw one important thing, that AI for the remote area or digital divide, what the other speaker also, other person also asked the question. So where is in the remote areas, to bridge the digital divide, we are talking about the NTN, non-terrestrial network, or some other satellite LEO communication, whatever we say. How this AI, you see any application of AI for this remote network bridging the digital divides? Any idea?
See, I can tell you a little bit of long way, but see, one thing is, essentially at this point, rural divide, I mean, digital divide is because, at least in the rural areas, because of coverage kind of issues. So one place where AI might play a role, again, it's all speculative at this point, I don't know, is how can it optimize the network? See, essentially, so there's a base station that's serving multiple users. Maybe there's one user who is like very, very far away, who is disconnected.
No, that's all. is already being done, as you also said, in one way or other way. In communication also, you are using this all ML models already.
Yes.
When the user is moving on place to other place, you are already churning the data and finding how it is moving and then making a handover and all. So it is all application of ML in one way or other way, right? But for the remote.
Yeah, maybe I'll take that because it's unfair to stump Ganti for something that
No,
I
no,
spoke
sir,
of.
yeah.
So, yeah, so anyway, so let's look at things like education. Let's look at things like health. There are real problems that exist in remote areas. You can set a hospital up, but you won't find doctors to reach there. Okay. Now, AI/ML has a role to play there. Directly, if you talk of networks, the way it plays a role is semantic communications. Semantic communications allows you to send much larger knowledge over a much narrower bandwidth. The other thing that happens is you can set up remote sites because they are self-healing. They are self-recovering. So there are multiple things that AI/ML does, and the final thing that it does is, because when you move towards AI/ML, eventually your cost comes down. And that is when it becomes more commercially viable to deploy in rural places. So there are multiple steps that will happen, not just one. Rural is a multiple set of things. Okay.
Thank you. I think we're running.
Thank you so much, sir, for the informative session. Thank you. Now I would like to invite Professor Manjesh K. Hanawal from IITB. Today he will enlighten us on AI and computational support for new use cases in 6G. Professor Manjesh K. Hanawal is professor in Industrial Engineering and Operation Research at IIT Bombay. He holds a BTech from NIT Bhopal and MS from IISc Bangalore and a PhD from INRIA, France. His research spans communication networks, machine learning, and cybersecurity with the contribution to 3GPP standards and multiple awards, including the Inspire Faculty Awards and Best Paper Honors. He has led successful teams in hackathons, securing top positions in 5G and 6G innovation challenges. Over to you, sir.
Okay, good afternoon, everyone. First of all, thanks for the invitation to speak here. It's an honor to speak in front of all the audience here. So today I'm going to talk about how this 6G is going to support new use cases. I mean, I will, as we go on, you will see that some of the use cases they are talking in 6G are like amazing. Like it looks like they are just coming from some fantasy world, but we are seeing that they are actually getting approved in the initial phases. We don't know whether they are going to get actually implemented. But now all those fantasy things, how the networks is going to support. So we'll try to see what is that's going on through this presentation. Okay, please move on. Okay, to begin with, yeah, we have this set things from IMT 2030, like, okay, there are 6 pillars we need to focus on. 3 of them are already just an enhancement from what was there in 2020 IMT. That is EMBB is going to be immersive communication. Massive mobile is going to be now massive communication, and ultra reliable low latency is going to be hyper reliable and low latency communication. But the new aspects here are AI and communication, integrated sensing and communication, and ubiquitous connectivity. As I understand, like India played some major role in pushing this ubiquitous connectivity into this IMT. I think maybe that's what one of the previous questions, what about the rural connectivity? That ubiquity connectivity is one focus area which will try to enhance the coverage and bring the unconnected into the connected domain. Now, all these aspects have some larger design principle. When we do this, we have to worry about sustainability, about ubiquitous intelligence. Of course, security and resiliency becomes important role, and getting everybody to this digital world. Okay, next slide, please. Okay, now where we are heading. If you just look into the path from IMT 2010, where the goal was just like, okay, just connect me, I want to talk, and also give me multimedia access through this mobile broadband on the mobile. Then we said, okay, fine, okay, this is there. I want this to be ultra low latency so that I can have more applications, new applications, and let machines also talk. Now this is done and dusted. Now we want everything to be automated. And also look for new applications that the network can bring in. Like as many of us already have realized, okay, 5G did not bring that kind of revenue the operators expected, so they want the real new use cases that will help them monetize. So they want to monetize whatever the current network, in what ways it could be used. The sensing seems to be one promising way, where the existing infrastructure, you just do the sensing and create new applications. Next slide, please. Okay, just if you look into these different usage scenarios, like immersive communication wants simultaneously connecting numerous devices, remote multisensory telepresence, holographic communication, supporting mixed traffic of video, audio, and other environmental data. Whereas sensing and communication wants active detection, movement tracking, high precision positioning, and environmental monitoring. And given the pervasive presence of base station, yes, this seems possible. And this is going to open a new application and use cases in the 6G domain. And now this AI and communication is talking about data acquisition, preparation, processing from different sources, and distributed AI model training, model sharing and distributed inference, and now providing the computation resources for this. Even though AI and communication has been put as a separate pillar, but I feel that that is playing just a supporting role for other cases. For example, immersive communication and sensing and other aspects. Next slide. Okay, hold on. Here, when we combine all these things, immersive communication, sensing, AI, this combination itself will open up new use cases. For example, like when we have sensing, AI, and immersive, we can create digital twins. Network is providing me the real mapping of my physical infrastructure through sensing. Now I have the AI which can make predictions on it. And now I have an immersive communication by which I can visualize, plan the things, and it can open new set of use cases. Next slide, please. Oh, this is, sorry, this display is not good. Okay, here I just want to highlight the fact that this AI journey started right from the 5G itself. If you look into the 5G architecture, at least from the core side, by the way, I'll be focusing more on the core side. I think Professor Kanti talked about the radio side. There was an architecture where the focus was mostly replace the existing EPC features with the other network functions in the core. But as the journey of the 5G started, we know that, oh, we have a new architecture here, which is very open architecture. By the way telecom networks are providing, maybe we are feeling like, okay, his telecom network is becoming an internet. His internet is absorbing telecom networks also. Like internet basically absorbed everything. All businesses are over the internet. And now, maybe except the radio part, rest of the things on the telecom net will also get absorbed by the internet. Like everything start looking, because almost all the protocols on the core side are now open standards, which are also used in the internet. But now once you are using the internet, oh fine, in internet already data collection is happening. People are processing, like, I mean, you open any browser, there are 1,000 cookies open up, collect your data, and propose to do analytics on it. So when you are using all this internet-based protocol, okay, there is already scope to collect a lot of data here. And then 3GPP proposed, okay, let's do this. When we have anyway built the core with this open architecture, let's put in new functions which does this job of cookies job, basically collect all the data that is possible. So they proposed this two network functions, NWDAF, that is network data analytic functions, and energy information functions, which is doing a lot of data analytics. Next slide, please. So this network data analytics function is one network function within the core, which is collected to any other network, all the other network functions in the core and collecting data from it. So its job is to retrieve, store, process the data, do local location services related data collection, data analytic exchange, ML model training, and ML model training using this analytic data repository function. And also provide the support for vertical federated learning and horizontal federated learning. So these network functions, which are already built in 5G, they already pave a platform or a groundwork to collect the data, process it, and start building AI/ML models. Next slide, please. Okay, maybe this is just details. We can skip. Next slide, please. Okay, so this network NWDF has two aspects to it: analytics logic function and model training. So analytics logic function is basically performing inference. Now network generate a lot of statistics. For example, network already knows how many people are there in a given area, how many people are going from one location to another location. Network has all this data now, and that data is real-time available, and also it is available in an aggregated form in the form of statistics. So that could be exploited, and also once you have the data, this network functions also enable you to train the model on the fly. And as Professor Ganti was highlighting, yes, training data is very crucial. You can't expect a fish to climb a tree. It is not trained for it. Whatever data you need, collect it locally wherever possible, then make it available, train, and apply in that same local scenario. You have collected it in your core for a particular, let's say, PLMN. Whatever it learned, try to apply it on the same PLMN. So that is where local data, local inference, local actions will possibly make things work. Next slide, please. And energy information is another crucial. Like for operators, this is a big concern. Like, I mean, if I have to really monetize, I need to bring down my capex. So how I'm going to do that? Maybe again, this is where AI can help actually, because AI is good in understanding the behavior and act on the behavioral aspects. If it can understand what's the energy consumption pattern, maybe it will be able to take some or suggest some decision. Okay, maybe this base station is not heavily loaded. Why don't you switch off? Maybe you don't need to instantiate these many UPF. That much data requirement is not there. Why to do that? Bring it down. Once we have this kind of energy information data available to us, yes, this can be done, and that is where this energy information function has been deliberately inserted in the core now. So this kind of collects energy information at multiple granularity. For example, it can collect data at a PDU session level or at a different flow level, even up to the slice level now. Next slide, please. Okay, we can skip this slide. I already mentioned it collects data at various levels. And the last thing about this is already, the network has already enabled the architecture for this federated learning. Now this is already, I mean, these are technical specifications. These are under the anvil now, like being implemented, or maybe possibly already implemented. Next slide, please. Okay, now this is where what things have been already done. Network already has this support for AI/ML training and data analytics from what it is collecting. But what 6G is now talking about is much, much more than this. What now 6G talk is, okay, you are collecting data from sensing, how to use it. We are now talking about AI agents, how the agents talk to each other. And we want them to do autonomous decision. Professor Ganti and all already highlight about context, intent, and all. If I just mention intent, how these AI autonomous bodies are going to act, nothing is going to happen magically. Like, I mean, network has to support it. So in the ongoing study, this is just a technical requirement being put by 3GPP. As of now, 15 new use cases on AI has been accepted, agreed, basically. There are a few more that has been agreed from the May meeting that happened in Japan, but they are yet to come into this document. On the integrated and sensing, there are 6 new use cases are already agreed. And immersive communication, there are 4. So what these use cases are talking about? They are talking about AI agents, how this AI agent need not be native. They could be from third party, how the information should be exposed to them, how these AI agents are going to be trained. For training, you need computational facility. Who is going to provide? Can networks themselves provide this computational facility? And when we are going to do large-scale training, we have to look for distributed aspects. And how to do that? Like network has to have an inbuilt support for this. So all these use cases are pertaining to these aspects. Next slide, please. Okay, so some of the things I want to highlight here. So we talked about AI native so much, but as of now, AI native is not defined as per 3GPP. What they have defined, I have put here, and this definition just came in the Japan meeting that happened last month only. As per 3GPP, AI agent is an automated intelligent entity capable of interacting with its environment, acquiring contextual information, reasoning, self-learning, decision-making, executing tasks, and autonomously, or in collaboration with other agents to achieve a specific goal. So now, any AI agent we are going to talk about network, it is capable of these many things. It can do self-learning, do autonomous decision. I mean, we are giving AI agent a lot of power here. And then AI service. So AI service is anything that can support AI-related activity which is provided by 6G core, native to the 6G core, considering required quality of services. And now, the other thing, like we heard so much about AI for network, network for AI. Yes, there is again debate. What should be the right terms? So 3GPP decided that, okay, we are not going to use AI for network or network for AI. We are going to use AI for 6G systems and 6G system for AI. These are the new terms which are approved, and now we are going to use. And also, what is 6G system? It is not something left open. 6G system consists of both the user equipment as well as the RAN as well as the core. All the 3 ends are there. So when we talk about AI, it's a full chain. User equipment, radio, as well as the core side now. Okay, next slide, please. Okay, now I will take you through few use cases that have been approved by 3GPP. I said there are 15 approved, but I selectively picked few to just to give a glimpse of what is going to come in 6G. This one use case is about optimizing 6G infrastructure utilization via resource exposure in 6G. We are talking about monetizing my networks, right, for the operators. Operators has acquired a lot of compute facilities. Now they want to expose it. It's not that my telecom resource is only going to do my telecom job. It could be used for other data crunching activities. So this is where, like, I mean, my network is there and there is a policy maker, and on the right side you see there is some third party who wants to use my telecom resources. For that, it need to know what resources my telecom network can provide. So now 3GPP, one of the requirement is now telecom network expose what resources it has in spare to share with others. Maybe like the concept of spectrum sharing is coming here to the core as well. So the requirements here are, the 6G network shall provide suitable APIs to allow authorized third parties to retrieve availability information about the computational resources. This is a requirement. Whether it really get implemented and we are going to see in the network, we have to wait maybe 5-6 years, but this has been agreed. Maybe some companies will pursue. The next slide, please. This is an use case on end-to-end AI connected cars. Now, many decisions will be made by AI agents, maybe on the user equipment, but where to do the computations? Compute is a big, like we can't think about AI without catering to the necessary computational powers. Maybe the compute, is it good enough on my user equipment itself? If not, where? Maybe I have to go to the edge server, which are on the telecom network itself. If that's not enough, maybe I have to go to the cloud, where even bigger computational facility can be provisioned. So now the requirement put is the 6G network shall be able to provide computer resources in the operator managed data networks for AI services. If you have any AI services, it could be your third-party AI services, but these AI services can put network to provision the computational resources. Next one. Okay, so this one is what I've got intrigued, like the way or what we can envision in the 6G. Like, I mean, let me spend a minute on this. This is a complicated. Like, I mean, the use case understand itself, it took me some time. The use case says, okay, there is a grandfather who want to host a party in his home for his kids and his grandkids and for his grandchildren. So he has an AI agent or an AI assistant which he can tell, okay, prepare my home for my arrival of children and grandchildren. That's it. This AI assistant agent should take this intent, see that with whom it need to collaborate this to get this task done. Maybe there is a robot there who can clean the home. Maybe I should tell the car to go and pick them, and maybe I need to order food delivery. So now there is an AI agent for each of these actions. I have an AI agent which my network will allot for me. It will send information to all of them, and it will in turn communicate with my children's AI agents, synchronize with them, match their timing, book all the things and keep ready and provide me the plan. This is the plan. Do you agree? So just imagine what kind of support network has to play, and this is something is what like some of the big companies, especially from China, are pushing. And at this point, okay, looks a little bit fantasy, but likely to be a reality. And in AI, what is fantasy can become reality very soon. So the requirements here are, the operator policy is like the 6G network shall support trusted network access to third-party AI agents and support mechanisms to expose information and coordination. Like it's a lot of autonomous decisions are happening here. Okay, next slide. Okay, I can skip this. Go to the next slide. Again, next slide, please. Okay, so this one use cases which IIT Bombay pushed into the 3GPP standard, which got again approved in the last meeting. So here we said that, okay, when we are going to talk to AI agents, maybe we'll be using computational facility from the edge server. But what if that edge server is congested? I may not be able to get the relevant inference on time. Maybe it is high computational processing capability, but by the time it goes there and come back, it may be too late for me. So this is where we said the edge server should expose the latency that is required for doing this task. And we feel that this is one of the crucial feature that will support many AI applications, which was just got approved in the last meeting. Next slide, please. Okay, and the last point I quickly want to highlight is this Sangam program, which DOT was driving. And under this program, there were many use cases that have been thought through, like how to handle disaster management, how to do transport mobility, how to assess the environment quality, and how telecom network can support healthcare. And these are various use cases where telecom network has a crucial role to play. Next slide, please. Okay, in the digital twin, we have this multiple layer. The bottom layer is about the geometric layer, where you get actual geometric layout of the city and all. The next layer, you kind of augmentate with various documents. And the third and fourth layer are important. The third layer is the interactive layer, where you get actual real-time information. And here where the sensing can actually play a role, when the networks can really sense what is the real scenario about the environment, they can sense and bring it here. And the fourth one is about AI, which is going to crunch on this data. And again, telecom networks can provide necessary computational provisions to do this computation here. So here, provide the necessary data and then provide the necessary computational capabilities to realize the digital twins. Next slide, please. So this is one use cases which again, IIT Bombay contributed to ITU, which is about flood management. When there is a flooding happening, telecom data can be useful to identify that. Telecom data, because based on the movement, a lot of traffic start going from there, people in panic mode, this data could be useful. So this could be used in planning. Maybe this part can go as an information to digital twin and which could be used for planning. Next slide, please. And another is comprehensive mobility plan. And in this use case, again, IIT Bombay was pretty much involved in the Sangam problem. So let's say I need to plan major infrastructure in the city, like where to put bridges, where to put roads. For this, I need to have a good understanding of the mobility pattern, like how people are migrating from which region to which region. For example, are the people moving more from Mumbai towards Pune or some other cities? Can I get this data anywhere easily? Telecom data is something very rich for this. I mean, telecom networks have this data, how many people moved from which place, and they can expose all this aggregated data, which could be used in such planning. So this is where, this is one thing we are now next trying to pursue with 3GPP, that yes, such data we can mandate telecom network to use, exposed to the third party, so that it could be used in building these digital twins. Okay, next slide, please. Okay, that's all overall view I wanted to give. Like now, if you see this, support for AI development and computation in 6G is coming, and this is going to make several use cases a reality. For example, one thing I mentioned about digital twins. And the sensing aided with AI will help build realistic digital replicas of the surroundings and the environment, which will help us like get the real city models and what's happening in real time and make decisions based on that. And this immersive communication, again aided with AI, will help me to do a better decision support systems. When I have this data, when I have this computational facility, I'm making predictions. Prediction is not the end. I have to make ultimately decision out of it. So for that, I need to visualize what happens if I do this, what happens I do this, what happens I do this. I can visualize this, all this through immersive communication, and then come up with a proper planning. And at the end, I mean, people are saying that even the core could be completely AI driven. Agentic AI. Agentic AI is one of the big things in the last 6G workshop that happened in Seoul. The thing is, everything, you just tell, okay, I want to talk. I mean, I don't need to connect like now to AMF and then UPF or signaling karo. Maybe all that agentic AI, I can maybe automate that process in a much better way. And entire architecture has to be possibly now that service-based interface we have now maybe has to be reworked in terms of agentic-based interfaces. So these are paradigm shift happening, and yeah, this is right time. I feel that teach more AI to our people. I agree that, yeah, we are losing out electrical engineers, but we don't need to make too many electrical engineers. Maybe teach them more AI. Yeah, I will make them intern learn electrical engineering and then make everything automated. But yeah, just keep in the mind that you teach this AI in such a way that they are able to learn electrical engineering on their own. With that, I will stop. Thank you. Sure.
Actually, I think already very surprising we have started talking on that 6G use cases. But I think as a country, we are already facing challenge on 5G itself. And what could be the possible causes as well as could be the remedies? Many of the things you said, we are still yet to do. I mean, we do not understand that type of reciprocation from the industry. We do not find adequate reciprocation of the academia as well. 100 5G labs has gone to many institutions, but when you go for review, don't find anything meaningful has been done over there. What could be done, basically, maybe one of
So
those?
I feel again, I think Professor Lal also appealed to that. 5G, just getting little more data rate than what is there already on the 4G, right? So that's what I feel, that not much excitement. See, everything is automated. I mean, it looks so fun. At least
And I have one more.
let others answer.
I have one more observation. I mean, please, before you give the reply. In fact, we really understand that the syllabuses in the UG and PG should be changed, and I think almost outdated. But I get afraid when you say this line, let whatever it comes up, I'll stick to Shannon's law.
Can I answer this first question also a little bit?
Sure.
See, 5G was not a success. I mean, I don't think that's a closed secret anymore. Okay, see, at least my understanding is that 6G is just going to be some basic variation of 5G with. At least that's what I mean. There's a law of inertia that is holding true in terms of economics, at least. So it's going to be 5G plus a little bit of AI. I mean, but at what scale it's going to change? I don't think it's going to be a very drastic change. At least, as you rightly pointed out, both industries also not. At least the operators are not very keen on doing a major investment at this point. But things are going to evolve. So essentially, the 5G. I mean, even now 4G is also still getting evolved. Technically, 4G also there are revisions happening. So 5G also will evolve, and that is what at some point we'll say it's. 6G. Okay. Coming back to your second question, sir, whatever we do, fundamentals are fundamentals. You cannot get over DSP or Shannon's theory. Has to be taught. Okay. I mean, at least in IITs, one of the philosophy that we have is you only teach the basics and leave the rest for them to learn. Okay. Once you learn Shannon's theory or basic digital communication theory, catching up anything else is like. It's pretty straightforward, this thing. But saying that now what we are trying to do is we are trying to introduce more electives in terms of at least, for example, AI-based communication or 6G or 5G. So for example, I teach a course on 5G, but that's an advanced course. The basic undergraduate education, I don't think we will, of course the AI is being taught, but not as specific use case for telecom or anything is not being happening. But basics, DSP, signal processing, signals and systems is something that's absolutely required. I think at least another 50 years. After that, I don't know. So I don't think we are there where we can give over all our knowledge to AI/ML at this point.
Yeah. Professor Ganti, yeah. So you already have a 5G testbed at IIT Madras. So any plan of upgrading it to make it AI ML enabled, what we are discussing today?
So one thing is we are actually now collecting data sets even with the existing thing, but it's not an AI enabled system. That's I mean there is a TTDF thing that is we have written. So there's a plan. At least our path of evolution for the test bed is that we are going to make it AI enabled. At least the framework, put the framework for data collection, show these use cases and other things. That plan is there.
So today I found you quite realistic when you spoke about these things. So I feel that AI can be used in network management systems. It can be used in things like network security, and in bringing these terrestrial network and non-terrestrial network together.
Yeah.
Thank you.
Absolutely, sir.
One small question.
Yeah, please, Manjesh. Yeah.
Actually, you were talking about NWDAF. Okay. So that caters for only computation, or it is ML, complete ML pipeline from source to things, sourcing, pre-processing, processing, analytics, and
Yeah,
finally sync.
it has two parts, I said, right? Like it has both the parts, like, I mean, it is collecting, it provides the pipeline for especially federated learning, it provides the entire pipeline. Yeah, yeah. Yeah. So just to answer that question, again, this is being a debate, like whether 6G should be drastically different from 5G. 5G people have invested. Those who want to make an ROI on that, they don't want much. But there is another thought that, I mean, 5G has not achieved much compared to 4G. So there has to be a drastic rethinking, maybe a drastic overhaul. So we have to see which one wins. But I think, yeah, within the industry, both voices are there now. Let's not make a minor tweaks, like let's change something, given that AI tools are all, maybe we can do a lot of automation.
Sir, I have a question. Professor Ganti, sir. Sir, now we are looking for quantum secure 5G core one side, and another side AI in 6G. Which will come first? And what we have to do, sir? Please guide.
So I don't understand. You are saying we are just talking about quantum computation, right?
Sir, PQC enabled 5G core.
See, PQC whether comes or not, we have to be ready today. I mean, that's the logic, right? Like, why wait till tomorrow? Like, I mean, that thing like store and decode tomorrow. So we should better migrate as early as possible. And already, I think NIST has standardized couple of PQC. I think it's in our best interest to migrate to them. And also the performance analysis show that by migrating to PQC, we are not losing much. It's not that we have to use just a generic handshaking algorithm or authentication. When we use the same with PQC, no performance loss. Why wait today? It's just like, I think we have to take it in a hurry. Maybe DOT has to make it a mandate, like start implementing.
Yeah. So now we have some few test labs. We have to make it PQC enabled, so that we can do testings.
Okay.
Pilot is required. No.
That's possible because implementing PQC is no big deal.
No, for that TTDF has to fund some of the labs. Sir, I am actually enticed to ask one question, and a very simple one. My name is Anil. It is to all three of you and maybe some of the senior policymakers sitting. I have been following 3GPP both in Chian and now currently happening in Prague. The whole contribution thing from Indian side is just being taken up by some academicians or academician turn entrepreneur or startups. Whereas when I see the contributions coming from the whole world, it is actually led by the leading names, and I'm not naming company, but we all know those 3, 4, 5 or 7 vendors, So what is stopping our Indian industry? And unless industry starts supporting these contribution and research of the academician, the same set of academicians are actually getting represented by these vendors in at least these forums. So what is it that we are lacking, and how do we solve that problem?
Okay, I mean, I don't know if this is online being recorded or not, maybe, but I'll tell you a short answer on this. So, see, we had a chicken and an egg problem. So we didn't have, I mean, at least 5 years, 6 years back, there was no big industry from India to represent in this kind of 3GPP forums. So at that point, a decision was made at the higher level saying that academics will go and represent, I mean, at least start this whole conversation going, because this is not something you can go in one day and they will start absorbing. It's like a basketball gang. okay, it takes time for you to get part of that gang, and then slowly only they'll allow you to play these things. So that was what was laid down by a lot of, I mean, Brajesh and Manjesh in the last few years, where we are going and we are attending things regularly. I mean, so there's a continuous participation of this thing. And now people also understand, they see earlier, at least in 3GPP, ITU was much more better because it was a government agency. I mean, it's a government organization. In 3GPP, there was a lot more resistance, but now, nevertheless, now because of what happened in the past 4 or 5 years, at least people are looking at our contributions and accepting it. Now, Indian industry is taking up. It's becoming a little bit bigger. Okay, so Tejas Networks, Velimni, these guys are becoming a little bit, CDOT, they're becoming much bigger. And now what is happening is, at least we are trying to handhold some of these companies, okay, to just get into this thing, and that at some point they have to take over. You are absolutely right that this is not the work of academics at all to attend 3GPP meetings. Okay, the only academics that you see in 3GPP meetings are from India, at least the highest percentage. We are doing good. There's nothing wrong about it. I mean, we are helping out, and it's also good for the students also. One good thing is, because of this, at least our students know what is happening exactly in terms of standardization, and their research also aligns to that. It's very, very good. I mean, a lot of people now coming from other countries who are visiting my lab are trying to see if they can do similar things. If you look at a country like US, there's academic participation in any of the standards meeting is almost zero, which is also not good. Okay, so in India, we have this opportunity to make this right balance between how much academics should participate and how much industry should participate. And we have to help large industry. It's not like one guy participating. I mean, bigger, as you said, big companies have to now take a lead on this and do this. There's no replacing that. We are seeing that this is increasing, slowly it's increasing, but I think another 4 or 5 years is when we are going to reach a critical mass. We can discuss more about this offline, I can tell you a lot more about this.
So thank you so much, everyone. Thank you so much, all our speakers. And now I would like to request Shri Rudra Narayan Pallai ji, member designate DOT, to kindly present the memento as a token of appreciation to all the speakers. So I would like to request Professor Brajesh Lal from IITD to kindly come forward. So now I would like to request Professor Radhakrishna Ganti from IMTM to kindly come forward. So now Professor Manjesh K. Hanawat from IITB. Wow. So now let's have a group photograph. One photograph group. Thank you so much, everyone. Thank you. So we are about to begin our focus group meeting in, say, about 5 to 10 minutes. So let's take a break for 10 minutes. Thank you. And the lunch is already ready, so you can go and have lunch in Atrium Hall. Okay? Enjoy your lunch.